When you drop an object, let's say you drop a pencil, you may have noticed this before that it falls down. And what we say in physics is that this is an example of free fall, or any object falling freely is called free fall. So put it in words to define how to define free fall, it's defined as the motion of an object due to the gravitational force only. What it means is that the only force when an object is falling down is going to be only the gravitational force or force of gravity. Now during the motion or during the fall, you may have noticed that the object gets faster or it speeds up. What it means is that the velocity is increasing since it's moving in the downward direction, and this increase in velocity is actually at a constant rate, which means that if it is increasing at a constant rate, it means that the acceleration is constant. Examples of free fall. Let's say we have an object or a rock that we're going to drop from our hand. Let's consider the example of dropping an object. The only force that is acting on this object is the gravitational force, and we're also going to ignore the air resistance, and we're not going to think of air impacting the motion of this object. Just to keep things simple. So let's say this time we're throwing up an object in the air, and again when the object gets out of your hand and goes up in the air, it's going to only experience one type of force, which is the gravitational force, and that's also going to pull it in the downward direction. And this is also an example of free fall, so it's still a free fall example. Third type of example that I'm going to show is an object we're going to throw, but this time we're going to throw it in a different way by making an angle and throwing the object in the air. So the object follows a path that I traced out on the screen. And again, when the object is in the air, there's no other forces acting on the object. It's only the gravitational force, and it's always pointing in the downward direction. So far in what we have seen in free fall is that the only force is gravitational force, or F of g. But from Newton's second law, we know that the net force means the sum of all the forces on an object. So if you're looking at free fall scenarios, the only force, which is gravitational force, and we know how much that can be calculated by an equation so far. So net force is from second law, and gravitational force is mass times the acceleration due to gravity. So which means that our acceleration is basically the acceleration due to gravity, or the 9.8 number that you have seen before in free fall. So we're taking an object that is falling on the surface of the earth or close to the surface of the earth. We're always going to use the acceleration as 9.8 meters per second square in the downward direction. Now it can be slightly different at different locations, but we're going to stick with this number. On the other hand, if we go to another surface, let's say we went to the moon, the value of g will be given to you, and that will be really small number, smaller than what we have on the surface of the earth. So let's take a look at our SUWAT, or the kinematic equations, how they can be used for free fall problems. So in that case, we are going to just switch the places for the acceleration, or the a is going to get replaced with a g, which means that's the acceleration due to gravity for free fall problems. And we also know that the value of g is 9.8 meters per second square in the downward direction, so you will have to use a negative number. Let's do some practice problems. Let's say we have a pencil and we're going to drop it from a certain height. Let's say it's 2 meters. And we want to find out how long will it take to reach the ground, or how much time will it take to touch the floor or the ground. So we're going to start off using the kinematic equations by listing down the variables. I know the height is 2 meters, and I also know that the question is asking to find the time. So if you think of dropping an object, you will notice that the object just falls without any velocity, initial velocity, so that's 0. And the acceleration for free fall is always going to be 9.8. We don't have any final velocity. We're going to solve the problem by plugging in the numbers. The only difference is that the negative sign will go with the height because it's falling in the downward direction. So that's why we have to use the displacement as a negative number and then solve for the time. Just a reminder, do not forget to take the square root when you solve this equation to get the time that it takes to reach the ground. Let's take another example. This time we're going to throw the pencil up in the air, and let's say we have given some velocity to the pencil or the object to go in the air. Let's say it's 5 meters per second. Our question is, how high will it reach before it starts falling down or returning to your hand? So it's again a kinematic equation problem. We'll start by listing down the variables. I don't know the height, that's what I'm finding. The initial velocity, since it's upward, I'm going to take it as a positive number. When it reaches the highest point, I know that it stops, so I will take the final velocity as 0. And the acceleration is again a free fall problem. I will use the number 9.8 in the downward direction. Plug in all the numbers that are given to you and solve the equation. Again, remember to plug in the number for acceleration as negative. When you solve this equation, you will notice that the negative sign actually cancels out and gives you a positive displacement. I will go ahead and solve the equation and write down the final answer for the displacement, and it means that the object is moving in the upward direction.